Welcome, my name is Nachiketa. I am one of the tutors at Alpine Prep Academy, specializing in Chem, HL, Math, AAHL, all IB, and Sports Science, HL and SL. I received a 41 out of 45 IB score in the May 2025 examination session, and I'm going to talk to you today about some chemistry, in particular, moles. So chemistry is a subject that is kind of the in-between between biology and physics. Biology as a course has been designed to make you revise and kind of memorize concepts and regurgitate them onto paper with very little application. Physics, on the other hand, is purely application-based. You get all your formulas and you just have to derive your answer based on those formulas that you will manipulate. Chemistry lies in the middle. So today I'm going to talk to you about moles. And here we have a question from the 2025 May examination session, paper 2, Chem HL. 3.162 grams of calcium carbonate, CaCO3, is reacted with 20 cm cubed of 4 mole per dm cubed hydrochloric acid. First question is write an equation for the reaction and include all state symbols. Now here's where you have to memorize a little bit. You have to understand the charges of each ion within each of these compounds. So take calcium, for example. Calcium has a charge of 2+. And carbonate has a charge of 2-. You need to know for certain ions like carbonate, phosphate, sulfate, etc. So, and the same thing for HCl. H has a charge of 1+, and Cl has a charge of 1-. So let's write the reactants on one side first. CaCO3, always include your state symbols when specified. It's honestly good practice to always include it when you write an equation. Plus HCl, which is aqueous. Forms. Okay, now what does it form? We understand that calcium is a positive ion and chloride is a negative ion, carbonate is a negative ion, and hydrogen is a positive ion. So essentially, this is again a memorization. You need to understand certain reactions. So carbonate reactions form a carbonate with hydrochloric acid always forms a chloride, a metal chloride, carbon dioxide, and water. So let's start with the chloride. It's going to be calcium chloride, so Ca, which has a charge of 2+, chloride, which has a charge of 1-. You're going to have to, the method I use is to cross the charges over so you can get your subscript of each component within a compound. So in this case, it's going to be CaCl2, as the 2 goes to the Cl, 2+. So this plus CO2, also CaCl2 is going to be aqueous, CO2, which is a gas, and water, H2O, which is a liquid. All right. Now, if you notice on the right-hand side, the product side of the equation, we have 2 hydrogens and 2 chlorines, and on the reactant side, we only have 1 of each. So therefore, for the mole balance, we're going to put a 2 in front of the HCl. And that's all for the first question. Second one is deduce which reactant is limiting. Okay, to find this, we have to find the moles of each compound of each reactant and figure out which one has more. Whichever has more is the non-limiting reactant. Whichever one has less is the limiting reactant. So let's start off. Moles of CaCO3. Remember your equation for moles, your formula for moles. Moles equals to mass over mR. So this gives us 3.162 grams over the mR of CaCO3 is nothing but 100.09. You have to find this out yourself using the formula booklet given. So this 100.09 grams per mole. This gives us 0.0316 moles. And since there's only one on the CaCO3. This is all we leave it at. Same thing for HCl. But with HCl, because it's aqueous, we use a different formula, which is moles equals to concentration times volume. Your volume is in dm cubed and your concentration in mole per dm cubed. So C times V. And we have both over here. So first, we're going to convert the volume into dm cubed. And the volume is, so to convert from cm cubed to dm cubed, you divide by 1,000. So it's 0.02 dm cubed, multiplied by 4 mole per dm cubed. This gives us 0.08 moles. However, we remember that there is a 2 in front of the HCl. Therefore, we have to, so for each one reactant, one mole of CaCO3 reacts with 2 moles of HCl. Therefore, we have to divide the HCl by 2, giving us 0.04 moles. Now we know the HCl has has more moles than CaCO3, hence CaCO3 is limiting. Lastly, we need to calculate the volume in dm cubed at STP of the gas produced. Now, we have to remember, STP in chemistry stands for standard temperature and pressure, and it's defined by IUPAC nomenclature as 0 degrees Celsius, or 273.15 Kelvin, 10 to the power of 5 pascals, which is nothing but 1 atmosphere. This is all in the formula booklet. And it's used as a reference point for measuring gas density and volume, where 1 mole of an ideal gas occupies roughly, in our formula booklet, 22.7 liters, or 22.7 dm cubed. So essentially for this, the gas produced is carbon dioxide, and we know that the CaCO3 is the limiting reactant. Therefore, when the reaction goes to completion, 0.0316 moles of CaCO3 has been used up and converted into 0.316 moles of carbon dioxide. And so carbon dioxide only has a 1 in front of it. It's only 1. Therefore, we only take 0.0316 moles. If it was 2, we would have to multiply 0.0316 by 2. So in this case, we have 0.0316 mole. And we want to multiply it by our the volume that it occupies, which is 22.7 dm cubed. So this times 22.7 dm cubed per mole, we get a volume of 0.717 dm cubed. And that's how you do it.